Okay, so next, let's write this method with the unplastic approach. That is, when the client receives this method to activate, you can use this method to execute. In the previous case, we explained it to you, right? And of course, there are some details. This writing method is quite simple, just a very conventional way of writing. And then this thing, it only executes on the client. And if we have some more complex functions, then it might need to be modified. Because this thing, you modify the health value. Then when you modify the health value on the server, you might have some underlying logic that needs to be handled. So the most important thing, this Lotus fans, it actually sometimes, for greater flexibility, you might want to get the previous value because after it finishes accepting this parameter, the value itself has already changed. So you actually have the previous value. You don't know what the previous value was. Sometimes you will compare and analyze the values from before and after. So can you get, of course you can. Then you can use this constitutive method on their side, or rather, that is, through these methods, their function signatures are not quite the same. You can see these are the function signatures of these types. Then presenting this is a value copy. This is a constant reference. Then this does not pass the signature, included in the signature. Then we mainly just need to write this for everyone. Just knowing these three methods is enough. Then there is a difference here. That is the way RepNotify works. In Blueprint is different from C++. That is, the set node in Blueprint. It will automatically call the RepNotify of that property for you if the Blueprint defines this parameter. Then generally speaking, referring to the Blueprint function that receives the property, it will not call the RepNotify, even if they modify this stuff. So you need to pay attention to this point. You need to understand this difference. So now we will write this for you. Now we create a new class. We create a pure class here. This class is relatively simple. We will directly start writing this for you. They are all relatively simple. First of all, we still need to provide this attribute, right? As for this attribute, we have 3 characters here, representing 3 different writing styles. We will put it in this position. As for these 3 writing styles, we map them to 3 different methods. These 3 different methods are respectively these 3 methods. As for these 3 methods, we need to create their corresponding implementations. Let's create them now. Okay, after creating the corresponding implementation, we better copy this root node as well, because sometimes it misses the root, meaning if you don't write it yourself. Okay. Then next, we need to register. As for this method, we can just copy the previous method over. It's a public override method, and then put it in here. For registration, mainly this few. First, call the parent class method, and at the same time put these properties in. That's it. Good. Okay. Here, it's quite obvious. We need to include the header file. Otherwise, it will report an error because it doesn't know what this macro is for. Good. In this case, actually, we've already done it. We can compile it, and it prints here this log every time it receives a modification. We won't print the log here. This log keeps refreshing. It's actually quite annoying. We directly use this method to hit. Okay, here we take this health map. Let's change it. Let's write the parameterless one first. Let's swap this one. Okay, the parameterless one is clearly the third. Okay, then the second one here is a constant reference. The third one is a value copy, and they both will pass in this previous value. Let's put this here. And this one is clearly, it cannot receive it. This is the situation of the previous value. Then we will change this value next. Then we will add a previous value to it. Here. Everyone change it. We put this less. Just leave it where it is. Okay, good. This way we are done. Let's compile it again. Okay, then here we will copy this tick function over. In the tick, we will observe our corresponding work. Then we add 1 to this one. Hits Hestawa Chua. Then we add 2 to health 2. Then we add 3 to health 13. Let's keep it simple. Don't make it too complicated. We only modify their values on the server to make a simple change. Then we can delete this piece of code. We can delete it because on our server, this place already clearly jumps to this client. We can change the color. Red, blue. Let's do a yellow one. Okay, now let's test these methods. See if it can successfully retrieve the previous value. Okay, compilation successful. Let's launch it. And here it also says in blueprint, when you set this value, it means you are essential. You must use this set node. Call it through the CD node. To have this, if you are essentially using this kind of, or in the case of red, if modifying it through a reference, it might not trigger this notify situation. Then here we'd better create a new C++ class. We don't have to create a new C++ class. We can call it here. We create it. Create its blueprint command. P. Then we put it in here. Put it here. Did we click the wrong thing here? We clicked wrong like this. Excuse me. I got mixed up here. Created it inside the C++. We still need to create a blueprint. Wait, let me delete that. No, it doesn't affect anything. This is usually given a BP. Then we create it. Okay, good. We have finished creating it. Next, we need to place this object in the right position. Put it here. Then we take the one from the original scene. Delete this object. Let's put this in. And now we only start 1, or we only start 1. Starting 2 is actually the same. Let's start 2. Okay. Let's look at this place. It doesn't seem to have produced the effect. Let's troubleshoot the cause. The cause is actually very simple because when we finished testing last time, it was modified. So we basically just changed its startup mode. Good. Let's check. It still doesn't have it, right? Let's check the reason again. This reason is also very simple because we found that the server here is increasing, but it is not executing here. This is because we did not enable this replication function. So in the actual scene, this object and that object are not linked together. They're both loaded, but they need to establish a connection. So we need to add this replication here. This is easy to miss. Let me show you where it's easy to miss. Yes, because this was created directly. We didn't write it line by line. When pasting, sometimes we might miss some lines. So this line is very critical because only when this replication function is enabled, where it's then on the server, establish a connection with this client's character. Then here we essentially directly used this network mode for judgment. So that rule wasn't actually used with it. So this is my fault. If we start it again, it should be normal this time. You see, it keeps outputting here, right? And you can see, obviously, our effect is also normal. You can see this value should be a threefold relationship. It should be about right. Yes, you can see 1 times, 2 times, 3 times. We also successfully printed this log on the client side. We also successfully received this upload on our server. This related code will not be executed. So at this point, we delete it. If we write it through blueprint, then how would this value be written? I'll still explain this part to you. We give BP, then Reputen will use it. If it's a blueprint, it's still the same for us. We are here. We give an integer. Okay, we give a health. And blueprints are relatively simple. Everyone should be able to understand it at a glance. Then, for this class, we change it to reply, add a notify, and for this condition, we won't change it. Then a method will be created here. Then in this method, we will print the current health value. Okay, now let's make it execute. Okay. So for this execution, we change it to 0. Change 0 to 0. Okay, then in the tick, we give it an increment. Let's see if this increment can successfully detect this property. Now let's test it with one client. Let's use 2. Same thing. We haven't dropped it in yet. Let's drop it in and test it. We found that this part did not trigger successfully. Right, so let's check the reason. Let's see if this works. Set health. Let's add a 1 to it. Let's test it again now. You can see it has successfully increased here. You'll notice the server. It is actually ahead of the client. That's roughly the situation. Right. You can see. So this sentence actually might be mapping to this sentence of ours. There might be some ways it doesn't really show up. Notify, you must call this set method. Only then can it be made to execute. So that's the situation. And there is a strange thing about it. You will find that its saver actually executed. This print, do you understand? That is its saver. A saver did execute. This thing, this is what I wanted to show you. This blueprint sometimes has a bit of interaction with the C++ level. This property header, actually there is such a difference. You will find that here the server printed this log because if, according to our understanding, this thing should not have been called only on the client side, it was actually called on our dedicated server, right? If we want it to print this information like this, at the code level, how should we modify it? So actually it should be like this, that is on our side, after changing this value. Then we might need to do it like this. Take this method, do it this way, do it like this. This health message, we set it to 1. This concept, I should have demonstrated it to you. This is the difference between Blueprint and C++. There is such a difference. This includes when using RPC. Sometimes there can also be such differences. So when using it specifically, you must never think of course. You just think it will be called at the Blueprint level. Then at the C++ level, you don't need to call it, or how to handle this information, and so on. So this path steal, we will write it for everyone. Write it properly. Here, let's see. It shows an error like this. The reason for the error is that we wrote it wrong here. Right here. It's not here, is it? This should be here. This is the correct way. There is no last of here. If it's critical. If this major issue is critical, we'll just ignore it. Okay, we forgot this last earlier. If you wrote it out, then there should be a missing %d here. Let's add it in. I saw it. Few issues. Okay, let's test it again now. Let's test it again now. So, for this part of the work, at the C++ level, you need to extract us this way. Just like when we were doing shooting earlier, I specifically emphasized to everyone. That part is so with Blueprint and C++, when you do property synchronization, you must keep these in mind. Because only after you've written this code with me once, will you realize there's actually such a big pitfall here? We should be this U-shaped. Let's start testing now. You can see this part might not be very convenient for us. To distinguish between the server and the client, take a look. As for the log here, it's not very convenient to print it out. It should be like this. It should be like this. Let's set it to A. Okay, and then obviously this is the server and this is the client. The plan should be slower. You can see because we start one first. Then you are here. You can see right here, this one at the back must have come later. This is synchronized on the server, right? So actually to make it easier to distinguish, we can do this. We add a server because this is definitely printed on the server. We might need to add it manually ourselves. Okay, let's test it now. If you don't write it this way, it actually here. It will definitely be directed to the client. Go to receive synchronization information, then Blueprint will help you. Code is on the server, but C++ will not help you call this. This is a bit of a pitfall here. Okay, let's test it again now. It should be this one. Use this class. Let's put one first. You can see there is a server here, but it might need to merge these together here. Yes. If you don't write it on the server, it won't call this server. This thing, he just prints this date on the customer list. There should be a few. A few dates are all printed to this. One script. Not very nice to look at. Okay, good. Then we'll stop here for this lesson. The first point we emphasized is this place. Repriority for will have differences. Then the call to this repriority for. Actually, it will also have differences. Okay,